towards the exercise. Okay, talking about the first question, the relative atomic mass of boron. The relative atomic mass of boron is 10.8. A sample of boron contains the isotopes 10, 10.5 and 11.5. What is the percentage of B11.5 atoms in the isotopic mixture of the sample? Okay, so how to solve that? Are you all with me? So how to solve this question? I'm moving towards one particular file. I don't know how I'm sharing with you now. Okay, so what is the there are two isotopes. So how we are solving it? We are taking the isotope, like 10 is the isotope, the mass of isotope, times the percentage, which is X, plus the other isotope. Please turn off your mic. Time the percentage into 100. And the answer for that is 10.8. Okay, are you there with me? So
Yes, sir.
let me modify a little bit. 10 times X. If X is 1%, one isotope, then 100 minus X is the other one. Okay, that's Y. So instead of Y, put 100 minus X, make X the subject of the equation. So how we are going to solve this? 10 times X plus 11 times 100 minus X divided by 100 is equal to 10.8. I want everyone to focus on this. So 10x plus 1100, I'm multiplying this multiplication, minus 11x divided by 100 is equal to 10.8. Are you with me? Are you with me, everyone?
Yes, sir.
Okay. Keep focus on this. So 10x and 11x. I'm getting minus x plus 1100. I'm taking this 100, multiplying it there. So how much I'll get from it? Yes, please. 10 times 8 multiplied by 100. How much I'll get?
1080?
1080.
80. Yes.
Everyone is clear with this? Take the calculator, do the multiplication. Now shifting this value here and bringing this one value here. So x is equal to 1100 minus 1080. Can someone do the
Okay,
calculation? Give me the answer.
20.
It is 20%. If x is 20, what is y? How much is y? Y is equal to 100 minus X. So 100
80.
minus 20 is equal to 80. Now let us see what was Y. So 10 is for the X, which is 20, and Y is for 11, which is 80. What are they asking for? What is the percentage of 11? So how much is the answer? Are we clear with this? See, 11 is with Y and 10 is with X. And the demand of the question is this area, 11B atoms in the isotopic mixture. Are you clear with this?
Yes, sir.
Our option is 11. Okay. The option that we got is D. Which of the following element has no paired p electrons in a single uncombined atom of the element? Single uncombined atom of the element. Which of the following element has no paired p electrons? Think about it for a while. Take your time, think about it for a while. What is your option? What are you getting?
Sir, D.
Huh?
Sir,
Someone
D.
is saying it's D. Okay. A bit louder, please, so that I can hear you.
Yes, sir. Sir, it's D.
It's D. Can you explain this, please?
Sir, because it have a full outer shell.
They're saying has no paired p electrons. No paired p electrons. Do you think that neon has unpaired electrons in it? Huh?
Sir, it's fluorine.
It's what?
Fluorine, sir. Fluorine.
Okay, okay, okay. See, let us do the configuration. Let's start from carbon. It is how many electrons are there? 1s2, 2s2, and 2p. 2 electrons are there, right? Now see here in carbon, and you decide about it then. I'll do every configuration in front of you. How many electrons should I put? They are unpaired electrons, this one, these ones. Okay, the demand is single uncombined atom of the element with no paired electrons, so they are no paired. Okay, not paired. Oxygen, let us see oxygen. Oxygen is 1s2, 2s2, and 2p, 4. So the p is having 4 electrons, 1 2 3, and this is a pairing. So this has a pairing, and oxygen in the atomic start has a pairing of electrons. So this is wrong. Let's talk about fluorine. Fluorine is having P5. 1, 2, 3, and then pairing. 5 electrons. So pairing, no, not the answer. Let's talk about neon. Neon is having all paired up. So no chance for neon even. They're all paired up. You can see now the pairing. So this is not even the answer. So we have option B, which is saying that carbon is a single atom, uncombined one, which is having no paired P. This is unpaired and this is unpaired. Are you clear with this?
Yes, sir.
Yes, sir.
Okay. Let's move on to question 3. Which of the following electronic configuration is that of an atom of an element which forms a simple ion with a charge of -3? A charge of -3, keep this in your mind. A simple ion. Which of the following electronic configuration? Let me repeat it once again. Which of the following electronic configuration? Yes, please. Anyone?
B.
B. Which forms a simple ion with a charge of -3. Yes, anyone else? Okay. Now, if you look into -3 means accepting electrons. So, accepting one electron with -1, two electron with -2, and third electron with minus. So, these are all electrons. So, 3 electrons should be accepted. Okay. Now, 3 electron acceptance. Let us talk about the first one, P. Can it accept 3 electrons? Then we'll talk about B. Can it accept 3 electrons? Then we'll talk about C. Can it accept 3 electrons? Then we'll talk about D. Can it accept 3 electrons? Okay. So let's talk about first of all the first one. It has 1 electron, and if the acceptance is there, it can accept one is already there in it. Okay. It can accept 1, 2, then pair 3, 4 and 5. So -5 can be a charge for this one. Then we have just give me a minute. So huh? No, this is face to face. I don't have any face to face. Okay, so -5 will be the charge. For this one, we have the second one B. We have 1 electron, second electron, 3 electrons are already there, so we need 3 more electrons for this. Okay, put 1 electron. This color is not favorable. Put another electron and another electron. You can see we have 3 electrons. So -3 probability is there in it. Let's talk about the other probability, which is 1 is 2, 2 is 2, 2p 6, 3 is 3p is completed. Now 3d and 4 is 2. So this can acceptance for 3d is much more. Like d is of 5 kinds. If it is only acceptance 1, 2, 3, 4 and 5. It has already 1 electron in 3d. So 1 is there. It can accept 2, 3, 4, 5, 6, 7, 8, 9. Only 9 electrons are needed for it. So in case of this, if acceptance is there, -9 will be the charge. Okay, but -3 is the only one which we can get from here, from B. Let us see the last one. So it is having 3D. Okay, 1, 2, 3, 4, 5. 3D, 3 is there. So 1, 2, 3 electrons are already there in it. The remaining electrons will be 4, 5, then 6, 7, 3 are there, 4 electrons now, 5, 6 and 7. So if acceptance was the charge, -7 could have been for this one. But They are preferring to release, this one also preferring to release. Only the 3p here is a probability to get that one. Okay? Any problem? Shall I move on?
Yes, sir.
Okay, I'm moving on to the next question. Okay, keep in mind every MCQ has a time. So you have a time for every MCQ which is 1 minute. Keep this in your mind. There are 20 MCQs in your paper and you are going to solve those MCQ within that time. This video is being recorded, it will be uploaded on the YouTube, so please watch that later on if you have any doubt. Question number 4 now. A sample of chlorine contained isotopes of mass number 35 and 37. The sample is analyzed in a mass spectrometer. How many peaks? How many peaks corresponding to Cl2 are recorded? How many peaks, number 4 of Cl2 are recorded? 1, 2 and 3 or 4? Let us see now. Cl2 is made of Cl, which will be 35 and 35. This is the first peak. Then another one Cl35, Cl37 with a plus charge, second peak. Okay, and then we have Cl37 and Cl37 with a plus charge. So how many peaks do you see?
3.
3.
3 peaks.
1, 2 and 3. So your option should be 3. Is it clear?
Yes, sir.
Okay, I'm moving forward. Question number 5 now. What is the atomic number of an element that contain atoms which have 4 unpaired electrons in their ground state? The atomic number of an element which has 4 unpaired electrons in their ground state. Ground state means normal state. Okay, let's do the configuration for each one and see. First of all, 6 electrons. So I'm doing the configuration here. It is 1s2, 2s2 and 2p2. Total electrons are 1, 2 and 3. Total electrons are 6. So if I explain this, how many unpaired electrons they're asking? 4, okay? How many unpaired do I see here? In this case,
2.
I can see only in P 1 and 2 unpaired. So 2 unpairs are there, unpaired electrons. Okay, let's talk about B. The configuration for B is 1s2, 2s2, 16 electrons are there, 2p6, 3s2, okay, 10, 12, 3s2 and 3p, 10, 12, 4. Now, let us explore the P with unpaired electrons here. 1, 2, 3, and the number of electrons that we have in the P are 1, up, down, this is up again, 4 electrons are there. So, how many unpaired electrons do you see? Only 2. So, this is not the option, this is not the option. Let's talk about C. The electronic configuration for C is, it's 22, okay? 1s2, 2s2, 2p6. 10 electrons are gone. 3s2, 3p6. 18 electrons. Still how many are left? 4 are left. Now after 3p, 4s and 3d. and electrons that are left with me are 4.
4.
So 2 electrons here and 2 electrons here. Now we'll expand 3D and see what is this condition here. 1, 2, 3, 4 and 5. Let us see the electrons in P. Okay. 1 electron and 2 electrons. How many electrons do you see here? Only 2.
2.
So even C is not the option. Let's talk about D. Configuration first of all, that is very important. It is for D, I am doing it right now. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and now I'm left with 3d. Okay, so 3d, how many electrons do I still have?
So we need 4. 3d4.
3d4. Now let us expand 3d here and see are we having 4 electrons or not. So of course 3d is having here 1, 2, 3, 4. 1 electron, second electron, third electron and fourth electron. So the total unpaired electrons are 4. So we are having 3d, 4 unpaired electrons. So the option is D. The correct option is D. Are we clear with this?
Wait, sir. It should be 4s. Sir, 4s2, 3d4. So just 22.
Yeah, and they're paired up.
No, sir. But in D, so it's 26, and if you add all these, you get 24.
No, pairing only happens in the subshell, not in the shells.
Sir, they are 24.
There are 24.
Yes, sir. 24,
sir.
sir. Yes, sir. 24.
Right now I have done 24. So put 2 more here in it. Okay. Then again it will be 26. It will be 4. Count it. This is 10
Yes, sir.
and this is also 10. Okay, 24, 2 more. Now one pair up. Khalas. How many are left? 1, 2, 3, 4. Again 4 electrons are left.
Yes, sir.
So 4 unpaired electrons are left in it.
Sir, I have a
Okay.
question, sir.
Yes, please.
Is there any other short way to find out this configuration?
Configuration.
Yes, sir.
Yes, of course. There is one. You want me to talk about the configuration now?
Yes, sir, and also to find out how many